All right, so in this video, I want to actually just fill in one small gap that I forgot to talk about in 6.3, and that's the domain of logs. And so we already know that when we talk about the log function, okay, let's just use y equals e to the x and y equals natural log of x for concreteness, and because e is the log that plays most nicely with calculus. E to the x, we know, looks like this. And so that's e to the x. And then the natural log of x is going to look like its mirror image reflected about the line y equals x. Okay, so that's going to look like this. And so from that observation, we already know a few things. We know that the domain of e to the x, the domain is all real numbers. And we know that the range, the set of all the outputs, is going to be all the positive real numbers. And therefore, when we talk about the inverse function, those reverse. So the domain of the natural log is all positive real numbers. The range is all real numbers. Okay, so that tells you that the natural log, and this is true actually of any log, but the natural log is only defined when x is positive for reasons that we talked about in class. Okay, so the natural log of x is only defined when x is positive. Now, what that tells us is that the domain, if I were to think about the function, I'm just going to use f of x here, but the domain of the function of the natural log of g of x, okay, is going to be the set of all the x values where g of x is positive. Okay, and so that's how you can find the domain of the natural log of a function. So just for example, this is not a complicated example, but not the easiest one. So just somewhere in the middle. Let's look at the function f of x is the natural log of x squared plus, what do I want to do? X squared plus 4x plus 3. Okay, let's actually do x squared minus 4x plus 3. Just so the algebra is just a touch nicer. Doesn't really matter, but there we go. So we want to figure out, so the domain of f is going to be the set of all the x values where x squared minus 4x plus 3 is positive. And then there's a few different ways that you can do this. I think the easiest way is very similar to what you do for the first derivative test. And that is first figure out where x squared minus 4x plus 3 is equal to 0. Okay, and then that splits up the real line into pieces. So this is going to be 0 when x is 1 or 3. Okay, so I'll just let you verify that that factors. You get x is 1 or 3 as the solutions. And therefore, you can split up the real line into 3 pieces. All the values up to 1, all the values between 1 and 3, and then all the values after 3. And notice that at the values 1 and 3, the function is 0. So those are not in the domain. So we're not including the endpoints here. And then what we can do is we can plug in test points, say 0, 2, and 4. And if we plug in 0, 2, and 4, we just have to figure out, is this quantity, this x squared minus 4x plus 3, positive, negative, or what? And then what does that tell us? And if you do it, it turns out that you'll get that it's positive at 0, it's negative at 2, and it's positive at 4. Okay, you could also just graph this function, and this is an easy enough function. It's a quadratic, it's a parabola. You could just graph it and get everything that way too. Okay, but this method holds up a little bit more generally. And so what this tells you is that the domain of f is going to be all the values up to but not including 1. So from negative infinity to 1, union all the values from 3 onward. Okay, so all the values from 3 onward. Okay, and so that's how you find the domain of logs in general. So whatever your function is on the inside of the log, you just have to figure out when is that positive. Those x values will be your domain.